So we looked at the beach compartments, and now I mentioned sea level change. So let's look briefly at sea level change. I also mentioned it in the context of the Ganga Brahmaputra Delta, for example, and we will look at it in the last chapter when we come to how ocean has been changing because of global warming or human activities. So two major processes can change sea level, right? When you say sea level, we are generally talking about global sea level. Locally also it can change because of human activities and other things, but we are generally now worrying about global change. So local tectonic processes can raise or lower Earth's crust, right? We talked about tsunami and how the tsunami actually changed the coastline of Sumatra and how it moved the island of Japan by 4 meters and so on and so forth, right? So tectonic activities can make a big difference. The other that's kind of a local change, what we had referred to early on as an isostatic change. Isostatic change. Okay, so continent can move, and locally relative to the land sea level can change. And then there is what is called eustatic change, which is worldwide changes in sea level. Eustatic means in good standing, which means the land is standing and the ocean is moving. Okay, so that tends to be a global change. Tectonic movements include obviously crustal uplift or subsidence, and you can have localized folding, faulting, tilting, which are geologic terms which we didn't actually get into, but nonetheless you can either look it up or just remember that geologic processes can change the land near the coast and change sea level, right? The example is the Pacific coast, which is currently being uplifted, which means the Pacific plate is pushing under, and then the US plate is being pushed up. Okay, so there are other places where we will see that the land is sinking, and we'll see why this happens. So that's an example of tectonic movements. And this is how it can happen. If you remember in the very first chapter what we learned, you have the continental crust and you have the mantle where you have the lithosphere and the asthenosphere. So when you have a glacier growing, did we define the glacier already? I think we did, but let me do it anyway. It's a little different than ice, especially sea ice. Ice is just freezing the water, whereas a glacier is when snow falls, it doesn't melt, and then more snow falls on top, and slowly it begins to get compressed, and you form ice by compressing frozen snow, right? So this is, unlike the actual ice, glacier can flow like a molasses, especially when it forms on the mountain sides and so on. It can flow into the ocean, etc. That we'll look at again. But what is the other big deal? When you keep moving lots of water from the ocean onto land as snow and build glaciers that can grow several kilometers thick. Remember, we said sea ice cannot get thick because it rejects brine, it sets up a circulation, and it also insulates the ocean, and the ocean cannot lose heat anymore, and so on and so forth. Except when you have a lake or a closed place where the ice can go to the bottom, so you can do drive on the lakes or do ice fishing if there is still some water below, and so on and so forth. So when you build so much glacier, that's a massive amount of water. Water is heavy, right? If you build several kilometers thick glacier, it's going to push down on the crust. And remember, the asthenosphere is plastic and it can flow, and the crust can bend. It breaks if you bend it too much, but nonetheless it bends. So you can see that when you put weight of the ice, there is subsidence of the continental crust, and there is, so if you put ice here, you can see here, glacier is being put here, the plate is pushed down, the crust is pushed down here, but it's being pushed up on either side. So this is subsidence, and there is uplift on either side, and the mantle is flowing to adjust to this crustal movement. right? Or crustal deformation is the better term. And when the glacier melts, like from the last ice age, the glacier disappeared, the part that was subsided and was pushed down by the glacier is going to bounce back, and the parts around it that were uplifted are going to subside now. Okay, so this is the isostatic adjustment under the glacier that we had already talked about. But when you build such massive glacier, you're going to take out tens of meters of water from the ocean. Ocean is giving water by evaporation, is being locked up in a glacier on land, which means sea level is going to drop. On the other hand, when the glacier melts because the orbital change happened, the ellipticity changes, the obliquity changes, the precession changes, amount of energy or the seasonal cycle of the energy coming in changes, and you have internal feedbacks which we haven't talked about yet. But you can imagine what they are. If you grow more ice, there is more albedo, so you're losing more energy. That will make it colder and will grow more ice. If the glacier melts, the albedo decreases, which means you absorb more energy. It gets warmer. You melt more glacier and so on, right? So those are the feedback. So when the glacier melts, all that water is going to be put back into the ocean. The sea level is going to rise. So since the last ice age ended, sea level has risen, obviously. So eustatic sea level changes are basically when the glacier melts and the water goes back into the ocean and the sea level rises everywhere. It can be caused by the formation or destruction of inland lakes. So if you've frozen the water or the lake is suddenly released into the ocean, then you are adding new water to the ocean. Or you can spread the sea level, so you can actually change the size of the basin or the depth of the ocean basin. This actually happens. It turns out that the ocean crust is constantly forming on a slow geologic time scale, or by melting or formation of glaciers, as I mentioned. And for global warming, we will see that there is a thermal expansion or contraction of seawater. So if you warm the water, it's going to expand. That's called thermostatic change. Okay, thermal expansion. Okay, so let me do this in the next slide because I want to spend a couple of minutes on it, and this is already long enough. But sea level change can change the coastline, and the sea level can change because the plates can move or glaciers can melt and form. And that's what the sea level change story is all about, because with global warming we're always trying to see how many glaciers are remaining, and if they melt, how much the sea level will rise, how many coastal places will go completely underwater. That's not funny, right? So we have to learn about that.